Hyperbolas, lesson 24, looking at hopefully the last video. We might have one more to go given the eccentricity and how long completing the square takes. Yes, completing the square is coming back in this video again. Now, we're looking at number 9 in our notes. We've got this particular hyperbola, and I know that it's a hyperbola and not an ellipse because of the subtraction sign that's sitting between the x and y. Now, let's go through all the little details. I need to find the vertices. I need to find the foci, the asymptotes. Now, you can, again, memorize all this information, all that you want. And it also asks me to sketch the graph. Okay, I am way too lazy to memorize all that information. My brain only fits so much, so what I'm going to memorize is how the y's and the x's and the points compare in terms of the axes. So I'm going to go to my graph here. Since there's no addition or subtractions in the x or y pieces up here, I know it's centered at the origin, so there's my center. 9 is actually 3 squared, meaning that in the y direction, I'm going to move up 3. 1, 2, 3, and down 1, 2, 3. Okay? I don't know if those are points on my graph just yet because I have to look at the x value as well. 1, 2, and then over at 1, 2. So there's those points, and I'm actually going to put x's there because I know that those x's are not actually on my graph because it's the negative portion. The negative portion is not actually part of my graph. So these are my vertices. These 2 points right here and here. So my vertices are 0, 3 and 0, -3, which means I know my foci will be 0, something and 0, the negative of that something. Now, I'm going to go ahead and try and identify what my foci are. How do I find my foci? Well, remember, my foci are always comma c and negative c. C squared is supposed to be equal to, for an ellipse, for an ellipse I'd have a plus sign, so it would be a squared minus b squared. But we're looking at a hyperbola that has a minus sign here, so the plus sign is here. So let me go ahead and do that. I have c squared is equal to 9 plus 4, which is equal to 13. So c is equal to the square root of 13, positively. Okay? So, for me to get to my foci, I'd have to go root 13. Now, root 13 is somewhere between 3 and 4, so there's 3. Up here would be 4. So my foci would be sitting here. There's 3. There's 4. Somewhere between there. Again, let's zoom in on that. This point is foci, this point is foci. The x's here and here are the actual, these 2 points are vertices. The x's are the foci. And not that it's that important, but in terms of the graph, it's just nice to know where they are. In terms of actually plotting them, I have root 13 and negative root 13. Now, where's the asymptotes and what does the graph look like? Well, I'm going to be real lazy about this. Okay, in terms of my graph, I'm going to go ahead and draw these dotted lines connecting all of those points and see that rectangle. Okay, I'm going to draw the lines through there and through there in red or dotted. Make sure they're in red or dotted. Don't do red. Do any other color other than red. And make sure they're dotted. Okay, because I know that this graph is focused on the y-axis. Okay, and has the empty space in terms of the x-axis. The empty space is going to be here, so this is going to have to approach like this and like this. And I have to know, what are the asymptote equations? Well, since it's supposed to be rise in terms of y and run in terms of x, it's going to be 3, the square root of 9, and 2, the square root of that. So it's going to be y minus h. Well, I didn't shift anywhere, so y equals, okay, plus or minus. It's going to be, again, the change in y over the change in x's. The change in y is 3, the change in x is 2, and then it's going to be times the x minus a number, but there's not going to be shifted at all. There is your asymptotes, your foci, your vertices, the picture of the graph based on that little rectangle helping us draw the asymptotes, and therefore helping us draw the graph. That there completes number 9. Let's move then swiftly into number 11. Number 11 is this particular equation. 4x squared minus 9y squared minus 16x plus 54y minus 29 equals to 0. That is not a pretty looking equation, but honestly it doesn't need to look pretty. How is one way that I know that this is definitely going to be a hyperbola and not ellipse? Okay, how do I know that this is definitely a hyperbola and not an ellipse? Well, the idea is the fact that this is a negative 9y squared. It's the fact that the y squared is a negative value, okay? So when I go to complete the square on this, I'm going to factor out a negative from the y's. I'm going to factor out a negative from the y's. So let me rearrange this and do some completing the square stuff. I'm going to have 4x squared minus the 16x. This is going to be plus some number. Okay, I don't know what number that is yet. This is going to be minus 9y squared plus 54y plus some number, I don't know what that number is yet, is equal to a positive 29 because I'm adding the 29 to this side. Okay? For me to actually complete the square, I have to factor out the largest value in front of x squared, so it's 4 times x squared minus 4x plus some number. Okay, remember the number that I'm going to add here? I'm also going to multiply it by 4 and add it to the other side. I'm now going to factor out a 9 from all my terms with y. So it's y squared minus, when I factor out a 9 from 54, I get 6y plus some number again. And this is equal to 29 plus 4 times some number. Okay. Minus 9 times some number. So let's go ahead and move this back out a little bit and complete the square on this. Okay, I'm going to take the negative 4, I'm going to divide it by 2, and I'm going to square it. Again, that's just the rule for completing the square. So this is a negative 2 quantity squared, so I'm adding 4 on the inside here, which means that I'm adding 4 on the inside over here. This then becomes a 4 times x minus 2. Again, the minus 2 right here tells me what's going to be inside here, squared. Now I'm going to have a minus 9 times something in terms of y. Well, it's going to be negative 6 divided by 2 squared, so it's going to be equal to a negative 3 squared, which is going to be a 9, and a 9 over here. Okay? So what's that going to give me? Well, if that's the case, I'm going to have a y minus 3, because that's where the minus 3 is right there. This is all going to be equal to a 29 plus 16, 4 times 4, minus 81. Huh. There's something very unique about this. I remember from the beginning said that this was going to have the negative in terms of y squared, but I feel like with these numbers, I am wrong. If I do this correctly, this is 2, 3, that's 45 right there, minus 81. 45 minus 81, I think that's going to be a value of a negative 36. Don't trust me, go ahead, 36 plus 45 is an 81, that's going to give you there. So I have this actual equation, x minus 2 squared minus 9 times y minus 3, sorry, this should be squared up here, squared. How do I get this to be in the specific form of a hyperbola? Well, I divide both sides, or all pieces, by the negative 36, because I want this side to be equal to a 1. So now I have 1 is equal to, well, 4 divided by 36 is actually going to be 1 over 9, but it's negative. And this one over here, negative over negative is positive, and 9 over 36 is 4. So I'm actually going to rearrange these and do y minus 3 squared divided by the 4. Again, 9 over 36 is positive 4. Minus 4 over 36 is a ninth, so x minus 2 squared divided by the 9. And this is the generic equation for this particular hyperbola. Now, if that's the case, I'm going to go through all the little details. Okay, actually, this is almost identical in concept to the one that we just did, but I'm going to go through all the little details for this one. Okay, I'm going to change this first on a new page of paper because I'm running out of room here. A y minus 3 to the power of 2 divided by 2 squared minus x minus 2 to the power of 2 divided by 3 squared is equal to 1. And I go to the larger number. Remember, the larger number in this case is the one that's positive. This y is in terms of my axes. So this particular question says, where's the center? Well, the center is going to be at an x value of a positive 2 and a y value of positive 3. Because, again, negatives on the inside, we shift it around. Then you have where are the vertices? Okay. Where are the foci? And where are the asymptotes? Now, for me to do all this information, I'm going to go ahead and just plot this thing. Okay. It's going to make me feel better about knowing where it is and how it works. So over here, okay, I'm going to go to the center 2, 3. 1, 2, 1, 2, 3. There's my center. That is the intersection point of the transverse and conjugate axes. Now, the transverse axis is going to be based on the y because that's a positive value. The y is with the positives, and it's going to be a value of 2. So, 1, 2. I'm going up 2 units in terms of y. I'm going down 2 units in terms of y. those connected together will be my, again, transverse axes. It corresponds to where my vertices are. So this and this would be my vertices. In terms of the x values, I'm going to go in the value of 3, okay, a value of 3 in the x direction. 1, 2, 3. So that point's going to be here. And I'm going to put an x there because I know I'm not plotting that point. That point is part of the, again, the rectangle that helps me graph this thing. 1, 2, 3 in this direction. And I have my vertices. They are over 2, up 3, up 2 more. Over 2, up 3 to get to the center, up 2 more, so 5. Over 2, up 3, minus 2, down to 1. Okay? Again, you can use the formulas for these. This paper right here, by all means, go for it. Okay? Either one of these sets of formulas. I don't care. I do it this way because this way makes more sense to me. Okay? It fits in my brain a lot better. Now, let's talk about where the foci of the asymptotes are. The foci, remember, are based on the formula c squared is equal to a squared plus b squared, not subtraction, because the subtraction point is here. Okay, so if this is the case, if I'm looking at this thing here, I have c squared is equal to my 4 plus 9, which is actually a nice value of 13. Not really nice, because you know c is equal to the square root of that. So I'm going to go ahead and, to my center, add the foci going up and going down. Okay, so it's going to be 2 comma 3 plus radical 13 and 2 comma 3 minus radical 13. Now just make sure I plotted these points correctly. Radical 13 is somewhere between 3 and 4, so 3 minus a value that's greater than 3 but less than 4 will give me a negative value. So that's an appropriate location for that foci. Let's plot this asymptotes and make sure I make sense out of those. Again, making the rectangle out of all that information there. I'm going to go ahead and draw the dotted lines through there for my asymptotes. Okay, a little bit off because of my graph isn't quite right. And I'm going to draw the line through this one as well. Okay, and I know that the graph is supposed to circle around the foci from that point, approaching those asymptotes. Okay, there's the graph. I've graphed this. The last thing I need to do is identify the asymptotes. Well, it's going to be y minus, well, the k value in y is, again, up 3. So y minus 3 is equal to a plus or minus some b over a or a over b. I'm not sure yet. Let me just put the x minus 2 value in there. Okay. And then I know that it's up a certain value over a certain value, such that I'm going up in terms of y, the y value of 2 up, and the x value of 3 over. Again, it being rise over run. So there's our equation. There's our equation for the asymptotes, both of them, both the negative slope one here and the positive slope one here. And that covers question number 11. We will do one more video for eccentricity and your application problem.